Hi, welcome back to CS170 fall session. We're covering chapter 9. So for this week, you can see that we've covered off on chapter 4 already, which was the continuation of chapter 4 from last week. And then today we'll hit chapter 9. I actually covered chapter 1 in the first week of class. But really, it's not that long of a chapter. It's pretty short intro chapter, so you can just read up on that in the textbook. So let's go ahead and hit chapter 9. Just a reminder, do try to send your emails directly to the Rutgers EDU account. The Canvas emails, probably a lot of the TAs and myself don't really check the Canvas mails, and there's a lot of things it doesn't really do in terms of like copying, pasting, the images and stuff like that. So when you send us mails, try to send us mails at the Rutgers EDU account. And if you have questions on stuff, I noticed some people had some problems with the HTML attaching it as a file. You want to drop in on the lab hours, make sure you get that in. You're going to obviously have to do that for your assignments. And then you also may have to upload something for for your exam. So make sure you're able to work with HTML files, okay? If you have a problem with that, do make sure you drop in for the lab hours. All right, so let's hit chapter 9. So these are the different topics for chapter 9. We talked about layer software. That's like the levels of abstraction that we talked about in week 1 of the class. Then there's this idea of like fetch execute cycle. And then these all like different parts of that fetch execute cycle for a computer. Memory, CPU, like you have the control unit, the arithmetic logic unit, and so on and so forth all the way down. Okay, so let's go at it. So here's the different points or topics within that. You have a processor, you have the OS, the operating system, software, your instructions, fetch execute cycle. Fetch execute cycle is something major topic. Make sure you understand each of those steps, memory and hardware. Okay, so this is kind of like a visual representation of that for your CPU. And you can see a link to it down here at the bottom. And you can see here on the left, you have your input, got your secondary storage, which is basically your memory. Could be like a memory stick, could be, something on the cloud, whatever, but something that's storing your data as well as the programs that will process that data. Okay, and then within your CPU, which is like this part right here, you have your control unit, your arithmetic logic unit, and then you have your local memory on board your CPU, right? That's like some fast working memory there. And then you have your output over here on the right-hand side, okay? So this breaks it down again, the hard drive, again, secondary storage. Probably most computers now, you're probably using solid state drives, but I guess some of the older computers would still have regular hard drives, which is like a spinning disk. And then you have your memory on your computer. And then again, same thing that we mentioned in the prior diagram, okay? And your IO, things like your mouse, your keyboard, stuff like that. Okay, so like I mentioned, this is like a topic we covered in the first week of class, which is levels of abstraction. So generally, most of you are not really thinking about the CPU and all the different components in there. But at the lowest level, yeah, that's what they're doing. It's basically doing some basic math instruction, albeit it's a whole bunch of them. Okay. So these are the 4 major parts again. Remember what I was saying before about your local memory? That's what this is, registers, right? These are basically fast working memory that's local to what the computer is doing, the CPU is doing in particular, okay? Okay, so they kind of represent this fetch, decode, execute cycle as like this little circle thing here. So the idea here is if you start off here with the fetch, okay? So basically you need to know, you have to get directions, what are you supposed to do, right? Generally, you're going to maybe add some numbers together, maybe you move some numbers around, shift some numbers left or right, something like that. But you have to get those instructions from somewhere. So you have to load those instructions up, okay? And then you have this idea of a counter, right? So you imagine, let's say you have 10 lines of a program. You have to keep track of where you are. Let's say you're in instruction number 1. Then the next time you come around, you're going to load up instruction number 2. And then you're going to do this part over here on the left. You're going to be doing a decode, right? And so you're going to be working on this register, right? Remember I was saying this register is like your fast local memory, okay? And then you're going to do an execute. You're going to execute this instruction, okay? And so this breaks it down more explicitly. Instead of like showing you this little visual thing here, you're going to see each of the steps here, okay? The only thing I would also note here, see, you still start off with the same thing with the instruction fetch here, and then you're still going to decode the instruction. But the other thing you want to note here is that you obviously have to get the data. It's one thing to get the instruction of what to do next, but you're usually acting on some data. So you have to go and fetch the data. That's what this data fetch step is, okay? And then you're also going to do something. Maybe you're adding, you know, something together, something like that. So you have to get that also. Then you're going to actually do the, you're going to do the execution, which on this diagram is down here at the bottom. Okay. And then you're going to have the result, obviously. So whatever you calculated, you're going to get the result, and then you're going to probably store it somewhere else. Okay. So here's like some example of like machine instruction here. Okay. So in this case, it's talking about the, you're telling the CPU to multiply a couple of numbers together here. Okay. So in this case, it's this 2000 and 2080. Okay. And note that they're not talking about the values of the number, but they're talking about the memory locations. Okay. So it's taking the numbers of whatever is stored. So you imagine these are like addresses. Okay. And these addresses at each address has a number. Could be number 1, could be number 2, whatever. So it's going to take whatever is at these addresses, calculate by multiplying them together, and then store the result into this address location, which is 4000. Okay. So main point you want to take away from here, when you're doing this machine instructions, whatever calculation you're doing, you're working in terms of whatever is in the memory address. Okay, so this and this, let's say, and then storing the result in this other memory address here. Okay. And computer clock is just like how fast each of these cycles, right? So imagine this is like, you know, one cycle here. And then this tells you how many, in this case, megahertz is millions of cycles per second, and gigahertz is billions of cycles per second. So each cycle is basically the time that it takes for the computer chip to process the instruction. So this idea of like cycle per clock tick, okay? So in this case here, it's basically saying, here's your instruction. And then when it processes it, it goes to the next step, let's say, right? So you remember this, the fetch, decode, execute, and store cycle. So each tick, it's going to go one space. So let's say we have this instruction 1, right? So in instruction 1, it takes 1 cycle to complete the fetch, another one to get the decode, and then the next one to get the execute, and then the store, right? So it's 4 distinct steps here. And then once it gets to that, then it loads up the next instruction, right? And it kind of goes through that again. But then there's this idea of pipelining, okay? So with pipelining, as you do the fetch here, then you go to the next slot to do a decode. But in the meantime, you have a free slot. You can go and get the next instruction, right? So that's what this is showing here, okay? So here you do the one instruction, and then when you get down to the next step, you're actually going to get the next instruction, which is instruction number 2, and so on and so forth. And you can see it goes all the way down to instruction 4. So what that means is, like, you know, when you get to instruction, let's say 4, the step 4, essentially, for instruction 1, you're actually able to be processing the first step for instruction 4. So you can see you're kind of processing like 4 of these in its pipeline. You're more efficiently processing compared to, like, if you waited for 4 of these, process all of that before you go to the next instruction. It would take longer, okay? So this is just to kind of draw an analogy between what we think of the different parts of the computer and the process to something that you can maybe relate to, like cooking something in the kitchen, okay? So you think about this, right? Here's the refrigerator, right? You can kind of draw the analogy of that to secondary storage, right? Something you have to go in there and get all those pieces, right? Your ingredients for your recipe, okay? So your kitchen countertop here would be your CPU. That's where you're doing your work. And here's your cutting board. You're going to be doing some chopping here, okay? So yeah, so let me rephrase that. So your local memory is over here. Your actual work is your chopping board. You're going to be cutting up stuff here. So you go to the secondary storage, which is your refrigerator. You get everything. Your recipe book here is where you're going to be looking at your instructions. Your ingredients are going to sit in the local memory, which is on your countertop. And then you're going to have your cutting board to do the work. Okay, this is just your memory, not your local memory. This is like your random access memory that your CPU will probably go to get the memory ingredients that it needs to work on in the CPU. Secondary memory, this will be your hard drive here, external optical drive, and so on. Your input output are things like your monitors, your printer, your keyboard, your mouse. Okay, this just talks about your memory locations here and the different values you can store at each point on your memory, okay? So each location, you're talking about 1 byte, right? Remember what a byte is? 8 bits equals to 1 byte. And this just says you have many simple operations that add up to layer on top of each other to give you the software that you run on the computer now. Right, and this is software layer. So the lowest layer, the operating system, probably you don't interact directly with too much here. And then you have all these things that build on top of that. Probably this highest level here, which are different programming languages, which will build applications, is probably what you're mostly interacting with, okay? Yeah, so that's pretty much what you look at with software layers, right? So operating system would be things that control like your printer, you have like these drivers, software drivers that tell you how to run different things. So if you have like a printer or something, there's something there that kind of tell you how to print. Let's say you want to print black and white, you want to print color, whatever. You have these software drivers that will allow your computer to interact at the operating system level with them. Okay, same thing for your monitor and whatever else that you hook up to your computer. Okay, so this kind of covers for chapter 9, nice and short, but do really pay attention to these concepts here. Make sure you understand this fetch, decode, execute cycle, and make sure you understand this analogy here between looking at your computer and your CPU and all of these different things here. Okay, and you have your reading over here. Take a look at it. Let me know if there's any questions. Okay, thank you.